Hi, I'm Michelle Edwards with FARO Technologies, and today we're going to learn more about the Vantage Tracker and the Ion Tracker. I'll be your personal tour guide as we talk more in depth about the functionality of the trackers, best practices, and how you're going to be using it in your measurement environment. In this video, we're going to review how to use the Retroprobe100 with the laser tracker. The Retroprobe100 allows you to get into places that you may have line of sight issues with, or to measure items or features that might be of a smaller nature that your SMR can't fit to or isn't appropriate for the measurement task. Our Retroprobe100 comes in a case with all of the accessories that you'll need. The unit itself has a wrist lanyard. We'll pull that out first. And comes in a case that protects the mirror. The wrist lanyard allows you to prevent from dropping it because you don't want to break it if you drop the lanyard. Inside the Retroprobe100 is an SMR in this back face here. In order to use it, you're going to attach a stylie to the back in this threaded area. We're going to attach the 6mm stylie today, and we have a couple choices available to us. Typically you get a 6mm, a couple of 3mm, as well as a 0 diameter or point adapter also. Also with the stylus you have nests available, and the nests are used whenever you need to measure one of your puck points and simulate the center point of a 1.5-inch SMR location. Each of these nests have etched inside of them a number for the stylie that they represent. So this, for instance, should be used with the 6mm ball, and then we have another for the 3 and another for the point as well. I'll show you how to use these in this video also. So we'll move this out of the way for a moment. And we have a setup here in which we've aligned to a CAD model of this part. The software has already been turned on and aligned with a couple of measurements to bring us into the same coordinate system. And what I want to show you today is the best way to use the Retroprobe100 in measuring small features. Now the first thing is, how do you capture the beam? Now there are a few different techniques, and one of the ones I prefer is to locate the laser beam itself. So there's a red dot. Place the ball over the red dot and then move the mirror in front of it. So if you move the mirror in front of the red dot and in line with the tracker, you'll see the green light activate on the tracker, showing that you've captured the beam and you're ready to measure with the Retroprobe100. So this is one of the easier techniques. Another is to look back at the mirror and line up the virtual SMR that's appearing in the mirror with the line of sight of the laser tracker. So if we try that method as well, we just move it around until we get it into place, the same way you would capture a beam just by using the SMR. So now you see the green light activate, we've captured that beam and we're ready to begin measuring. Now capturing the beam in relation to the laser tracker is one aspect. The other is making sure you tell the software that you're using the appropriate adapter. Just as you would change probes for any type of SMR change or adapter change, whether you're using a pin nest or whether you switch size SMRs from the 1.5-inch SMR to a 1/2-inch SMR, you always need to indicate this in your software so that the appropriate offsets for the radius of the ball can be applied as your calculations are done. We do this in the Measure 10 software by selecting P on the keyboard for probes, or by going to the Device menu and Hardware Configuration. And in your Probe Edit dialog, you can choose Probe Management to select the probe and edit. You can also do this from within the measurement command itself. So if I want to measure a feature, and we'll start with something basic like a plane, I'll choose the Measure menu and select Plane. And within the measurement dialog, I have a choice to change my adapter there as well. So if I'm using the Retroprobe100 series, I'll select that here and select the appropriate adapter, in our case, the 6mm styly probe. From here I can begin measuring. So I'm going to locate that beam, pick it up with the Retroprobe, and measure on the surface of the plate. So we want to hold the ball in contact with the surface of the plate, trigger the tracker to take a point, and take as many points as we like on the surface. Now for planes, of course, we need at least 3 points to describe the plane, and end the command. Now typically if you're using a Retroprobe, it's because you can't reach an object or because there's a line of sight issue or your feature is too small. For instance, we have 5mm holes drilled in this particular plate, and it would be difficult to measure these 5mm holes with a 1.5-inch SMR. That makes it an excellent task for the Retroprobe. So if we want to measure that, we will escape out of our plane command and select a single point circle command. Now for this single point circle, we just want to make sure that we rest the stylus inside the circle, and the diameter will be captured with a single point. Rest, take the point, and end the command. All right. Now another reason might be that you're capturing a curved surface where line of sight might be an issue. For this we can also use the inspect surface command and take single points on the surface of our part. Now this is how you use the Retroprobe100, how to capture the beam, and some areas in which you might use it in inspection. Now another reason you may need to use it is, of course, if the line of sight for your move device position or for your repeatable puck points is obstructed from another object. So if you have a puck point that you've captured with the 1.5 SMR, it would be over here on your part. So if we capture that beam, place the puck there, measure a point, this point, of course, is taken at ball center of your 1.5-inch SMR. Now if we need to check that point, but we're checking it with the Retroprobe, then we would place the adapter for the 6mm instead of the SMR. Then the Retroprobe, by capturing the beam, can be placed inside the divot within this ball and measure that point, which would coincide with the same point taken with the 1.5-inch SMR. So this video has shown you how to use the Retroprobe100 and a couple of cases where the Retroprobe100 might be the tool that you would select for the job.